welcome to the another topic. Our today's topic is Introduction to Bayesian Classification. So, in Bayesian classification, we will see about this is the actually algorithm that is based on the Bayes theorem. So, we will see about that. Myself, Priyanka Gupta. I am assistant professor in Department of Computer Science and Engineering, Data Science at Institute of Aeronautical Engineering, Hyderabad. Today, I'll talk about what is marginal probability, joint probability, and conditional probability. So, before going into the conditional probability, we have to know about what is the marginal, joint, and conditional probability. Then we will see how to calculate conditional probability. Then all of the Bayesian theorem that is based on the conditional probability. We will see what is the Bayesian theorem. Then we will go into the naive Bayes classifier. That is the algorithm we will see. After that, if we will got the probability, we will check how to know if the current result is correct or not. Then some of the measures are there to check it, and then we will find the accuracy of the model, if the how accurate the model is predicting or not. So for that we will see some of the measures. Let's start. Marginal probability. So before going into the Bayes theorem, we should know marginal, joint, and conditional probability. In probability, basically, a real valued function defined over the sample space. What is sample space? Sample space S is nothing but that is a whole population of that we are taking some of the values. So that is a sample space for that particular value. So that is sample space of a random experiment that is called as a random variable. So what is random variable? The probability, in probability, some of the real valued function will be there. So in that sample space of that experiment, some of the real valued functions are there. That is called as a random variable, right? So now we will go into the marginal probability. Marginal probability is the probability of the event. Some event is there. So the marginal probability is the probability of event irrespective of the other random variable, right? So if the random variable is independent, if some of the random variables are there and they are independent, then it is the probability of the event directly. If they are not there, then if the variable is dependent upon other variables also, then the marginal probability will be there. Then the dependency will be there, and then the marginal probability will be there. The marginal probability will be the probability of all of the event that will be summed over the all outcomes. What are the different outcomes are coming over the one test? So that will be the probability of sum of them, all the events. So all the events, that is for the dependent variable. So for that is called as a sum rule. So for that, every time, for every iteration, the value will be there. Then in either like that, after all it will be calculated as summed value. That will be the summed event. So marginal probability is the probability of an event that is irrespective of the outcome of the other random variable. That is, if we will take an example P of A. So simply we can say like that. So here the joint probability will be the probability of two or more than two events, simultaneous event, that often described as a event A and B from two dependent random variable. So that is a difference between the marginal and joint probability. So joint probability is the probability of two or more simultaneous events that is often described in the terms of event A and B that is coming from the two dependent random variables. So for example, X and Y. The joint probability that is often summarized, that will be summarized as just the outcome, that is A and B. We have to write like A and B, right? So now the joint probability of two or more simultaneous events, that is P, A and B, we can also write like P, A and B. That was for one event, that is for two events. So how to write? P, A and B, and for same like that we can also write P, A, comma B. So that will be the joint probability for two or more events. Joint probability can be calculated using the conditional probability. So what is conditional probability? That is P, A, comma B, that we can write as a joint probability, is equal to A depends B, that into P, B. So that is the conditional probability as a joint probability. So here we will get the P, A of B, right? So this is called as a product rule. This is called as a product rule because here we are using the product sign. So that will be the product of the events. So this is called the product rule. Importantly, the joint probability will be symmetrical. So how it will be symmetrical? Like if we are writing P, A, comma B, that will also be equal to will be by P, B, comma A. So that is a symmetrical rule. That is a symmetrical rule. So now the conditional probability comes. The conditional probability is the probability of two events, of one event. Suppose for one event, given the occurrence of another event. So if the other event is also occurring there, so we have to find out the one event's probability. So often that is described in terms of, if you will take an example of if A and B are two particular events, so A and B from two dependence random variable will be X and Y. Here A and B. So the probability of one or more events given the occurrence of another events. So if we are writing as P, A given B. So for conditional probability, we have to find out this of the probability. So if we will write P, A given B, so that means we have to find out the conditional probability for the two of the events, that are A and B, right? So here probability of the one or two events would given the occurrence of another event, that is A and B. So we have to write it like P, A given B. We can also write P, A, this is sign given B. The conditional probability can be calculated using the joint probability. So how we have seen in joint probability, we have to write like P, A given B is equal to P, A, comma B. A, comma B is also same as A given B divided by P of B. So that will be calculated like that. The other property is the conditional probability will not be symmetrical. For example, P, A given B will not be equal to P, B given A. So if one event is occurring, that will be dependent on the other event, but we cannot write like the other also is depending on the one event, right? So if we will write in the same terms in the alternate way to calculate the probability, conditional probability, so that will be like that. Now there will be the another example. If suppose one conditional probability can be calculated using the other conditional probability. For example, if you are having the P, A given B is equal to P, B given A into the P, A divided by P, A, P, B. Right? So what I have said, P, A given B is equal to P, B given A into P, A divided by P, B. Right? So the reverse will also be true for that. Like that, if we are writing the P, B given A is equal to P, A given B into P, B divided by P, A. So that will be same like as we have write like P A given B. So that is also possible. We can write some of the events like that. So this alternate calculation of the conditional probability is referred to as a Bayes rule. So if some of the time we are writing the rules like that, so that rule will be called as a Bayes rule or Bayes theorem, right? Bayes theorem. So Bayes theorem named after the Reverd Thomas Bayes. The scientist's name was Reverd Thomas Bayes, who is credited with the first describing it. He have described that Bayes theorem. So it is grammatically correct to refer to it as a Bayes apostrophe theorem. But we are ignoring while we are commonly writing like that Bayes theorem. So we can also write like Bayes theorem, Bayes. That is nothing but the normal writing abbreviations. So that we have to omit as a apostrophe for the simplicity. So there will be the two types of probability. That is, first is prior probability and second is posterior probability. So prior probability will be the P of A. If for some event we are writing, that will be the P of A. For other event we are writing the posterior probability. That will be if the other one event is depending on the other event, P A given B. So that will be the posterior probability, right? Where B will be the data tuple and the A will be the some hypothesis. On that hypothesis we have to think about the other terms. Now, so according to the Bayes theorem, what is the Bayes theorem? That is P A given B is equal to P B given A into P A divided by P B. So that is nothing but the Bayes theorem. That is comes from those of the probability, conditional probability and joint probability. So suppose if A is the hypothesis, if we are taking A as a hypothesis, right? And B, what is B? B is the information about the person. If Anna is a person who will buy the computer, that will be the hypothesis A. And B is the information about that person, that is that she is going to buy the computer on the some of the basics. So what are the basis for that? Anna, that is the 35-year lady, and she is having the fair credit rating. That she is also the income of $40,000 per year. So that will be the condition for the Anna, right? So posterior probability P A given B, that is nothing but the probability that Anna is going to buy the computer given the condition that we know her age, we already know her age, income and the credit rating. So on the behalf of that, we have to know about the A. If we know about the B information, right? So the prior probability P of A, that is the probability that Anna will buy the computer, that regardless of knowing the age, income and credit rating. So here we don't have to know about the Anna information anymore. So that will be the prior probability. Here the term is P B given A. So that will be the likelihood. That is the likelihood probability that someone is 35 years old. Someone is having the fair credit rating and they earn $40,000 per year and has bought the computer here. And so here all the condition will be there, the likelihood as a likelihood. So here all the information about the person, whether they have to buy the computer or not, all will be there in likelihood. What will be the evidence? P of B. P of B were written there in the Bayes theorem. So that is the probability that Anna is 35-year-old and she has a fair credit rating, that she earns $40,000 per year. So that will be the simple evidence for the other events. Now, in the Bayesian interpretation, probability determines the degree of belief. That is nothing, probability is nothing but that is the degree of belief we are going to believe for some event is occurring or not. The event is going to occur or not. So two of the terms that works like a binary, either yes or no, right? So Bayes theorem connect the degree of belief into the hypothesis before and after the accounting for evidence. So either the event is going to occur, either it is not going to occur. The Bayes theorem that is going to connect the degree of belief before and after the event that is going to occur. So that is nothing but we are accounting that for the belief, that we are accounting that for the evidence, that is for the event that is going to happen or not. So for example, if we will consider an example of the coin, so there will be the coin that is having the tail, right? Tail and head. So if we toss a coin, if we are going to toss the coin, so then we will get either head or tail, right? So and that the percent of occurrence of either head or tail is going to occur, that is 50%. That is 50%. So if the coin will be flipped, it will be turned number of times. So the outcome will be observed, and the degree of belief may arise. They may arise, fall, and remain the same depending on the outcome. So it will be depend on the occurrence, how many times the head and tail is coming. So that will totally depend upon the outcome. Either it is true or not, like that. So the coin will be flipped number of times. The outcome will be based on the degree of belief. So if there is that comes in the outcome as a yes, no, like it may fall, rise, and remain like same as earlier. Sometimes if the condition is, if sometimes B given A is referred to as a likelihood and PB is referred to as a evidence. So if we are that is the like same, that is not like same, that is totally different side of that earlier rule we have written. So if we will write like that, so we will call as a B given A is the likelihood and PB is the evidence for that event. Now, so this is going to allow the Bayes theorem to be restated. So how to restate? We can also write again the Bayes theorem. So that will be the posterior is equal to likelihood into prior divided by evidence. That is opposite of that rule what we have written earlier. So here the posterior will be equal to likelihood into prior divided by evidence. Right? So for example, if we have to know about what is the probability that there is a fire given that there is a smoke. So if there is a smoke, how to find out the fire occurs, right? So where P of fire is the prior. Here the prior will be the P of fire. The likelihood will be the P of smoke given fire. Because of fire, the smoke came, right? And then the P of smoke is the evidence. Because the evidence was there earlier, smoke, then only we are going to find out if there is fire or not, right? So we will write the Bayes theorem for that. What will be the Bayes rule? The Bayes rule will be the P fire given smoke is equal to P smoke given fire into P fire divided by P smoke. So that is the whole Bayes rule for that simple event. Now the classifier comes as naive-Bayes classifier. Naive-Bayes classifier. So naive-Bayes is the term that is collectively used for the classification algorithm, right? That are based on the Bayes theorem. So that was because the Bayes theorem was based on the conditional probability, and here we are taking the naive-Bayes algorithm, that is classifier, that is for classification. So that is nothing but that is based on the Bayes theorem basically. So the Bayes theorem classifier algorithm, one of the most simple and powerful algorithm in the data analytics. When we are doing the data analytics, that naive-Bayes we find as a more good and powerful algorithm to use. It is a classification based on the Bayes theorem. That is the formula. Bayes theorem formula, and with some of the assumption will be occur of the independence among the some of the predictors, right? So the algorithm is naive. Why we are calling it as naive? Is this dumb? Is this don't work like that? So it is not new, no, because it works on general assumptions. It works on general assumptions that the presence of a particular feature in a class is independent or totally unrelated to the presence of some other feature in the same class. So that's why we are calling it as a naive Bayes classifier. Bayes comes from the Bayes theorem. So the Bayes theorem is often referred to as the posterior probability equals the prior probability that times the likelihood ratio. So simply the Bayes theorem we can call as the posterior probability equals to the prior probability that times the likelihood ratio. For example, if there is a table in this example that is having the credit score and that is having the default yes and no classes. So some of the records are there that is having the 100 to 200 credit score, that is the CIBIL score. Yes, there some of the numbers are there. For the second class is the 2012 400, third is 401 to 600, and other is 1 to 600 to 800. So like this, the one example frequency table is there. So the problem is to predict if a candidate is having the credit score of 180, that is comes under this 100 to 200, will default on a loan or not. So if we are going, if some of the bank they are going to give the loan to that particular person or not. So consider the following frequency table for calculating the likelihood of default. We will see some of the steps. So since the candidate has credit score of 180 and we have to predict about that label, so we will follow some of the steps. So in the first step, for to do the find out the new, we have to apply the naive Bayes classifier. We have to calculate the prior probability in first step. So we have to calculate the prior probability for each of the class that is having the S and no. So P of S we want to calculate. So P of yes will be the 11 divided by 29. So that comes as a 0.379. So from where it has come? It has come from the Bayes theorem. It has come from the Bayes theorem. So P of S, how many? If we want to get the P of S, we have to calculate from that Bayes theorem. So that comes under 0.379. Now we have to get the P of 180. So here P of 100 minus 100 to 200, that will be that will comes under 10 times divided by 29 total, and that will come as a 0.345. In the second step, we have to calculate the likelihood probability for each of the attribute for each class. So here P of 100, P of 180 that given as if P of 180 and that is having the S, and that will be the 6 by 11 and 0.545. So that will be the likelihood probability for that particular condition. In the step 3, we have to calculate the posterior probability. So for that, we have to calculate the P yes given 180 is equal to P of 180 given as is into P of S that divided by P of 180. So that we have already calculated P of 100 to 200, that was the 0.545 into P of S, that is 0.379, that is divided by 0.345. So these three of the terms we have already calculated. So now that result that is coming at as a 0.5989. So that so for CM we can round it at the 0.599. So that is the conditional probability for the P if P S given 180. So in the next step, that is the fourth step, we have to make the predictions for the same model. So before, since the probability of the candidate defaulting is more than 50%, that is more than 50%, 599, that is 59 is the more than 50%. So it is assumed that significance level and it can differ based on the use case. So we can say that the candidate will be defaultly given the loan from the bank. Yes, he is going to be given loan. Right. So now, how to know if result is correct or not? What are the results we have got from that Bayes theorem, conditional probability, that is correct or not? So the accuracy will be there. The accuracy of classification will be there. So the accuracy of classification can be find out using a confusion matrix. So in the right hand side, we can see here one of the table is there, that is having the in the front we can see as a predicted class. In the left hand side we can see here actual class, right? So here P and N is there, here also P and N is there, right? So P is stand for positive, N is negative. Here for actual class P and predicted class P, that is having the true positive result, TP, that is true positive. If we are having the actual class P and the predicted class negative, then we are having the false negative, right? If we are having the actual class N, actual class negative and predicted class positive, then false positive will be there, FP. If we are having the actual class negative and predicted class also is negative, that will be the true negative. That is the real negative. That will be the TN. So that is the confusion matrix that is based on the binary classification. If two of the classes will be there, then that confusion matrix will work, right? So the confusion matrix is nothing, that is a n by n matrix used for the evaluating the performance of a classification model. So here the n is the number of target classes. So here we have seen for this for the two of the classes, but that can be up to the n into n. So how many class we have to predict? For that we have to make the confusion matrix for that, right? So the matrix compare the actual target value with the predicted by the model. So what are the predicted values are there, that will be compared with the actual value is there, right? So if we will compare and the formula is there to calculate that accuracy, so we will get the actual result for that. So for a binary classification problem, we would have a 2 by 2 matrix as shown below with the 4 value. So that is nothing but these are the 4 classes will be there. So where if we have seen the true positive TP, so that is the number of positive examples labeled as such. FP, that is nothing but the false positive, that is a number of given examples that is labeled as positive, that is a class level positive. The true negative TN, that is nothing but the number of negative examples that labeled as a such. False negative, that is nothing but the number of positive examples that is labeled as a negative. So that was the abbreviation of the different 4 terms. Now, finding accuracy of the classification. So after the model is there, that is going to predict some of the result, and for that we also having the result from the actual classes. So we have to compare the accuracy. We have to find out the accuracy of the model, if the model is giving the actual result or not from the actual class. So accuracy gives the result of total correct predictions out of all the predictions. So the accuracy formula will be there, that is accuracy is equal to TP plus TN, that is true positive, true negative divided by all of the terms, true positive, true negative, false positive and false negative. So that will be the accuracy of the model. Like by this formula we can get the accuracy of the model. Precision. What is precision? Precision answers the following questions. What are the out of all the examples of the classifier labeled as a positive, what are the fraction were corrected or not? So if the result is correct or not, so we will get that from the precision. Precision is equal to, the formula is TP, true positive divided by true positive plus false positive. So all the false and negative positive, that will be calculated, that will be divided by that will be the dividend will be the TP plus FP by that will be the TP. So TP divided by TP plus FP. So what is recall here? Recall answers on we can call as sensitivity. So sensitivity is out of all the positive examples there were, what fractions did the classifier pick up? What are the fractions were there that will be that classifier has taken up? So the recall that will be calculated by recall is equal to true positive divided by true positive plus false negative. That was the that is the equation for that, formula for that to calculate the recall of sensitivity. Now the specificity come. The probability of a negative result, the constituent that will be conditioned by truly begin negative. That is true, but that is being negative. So that will the formula will be there, specificity, that is true negative divided by true negative plus false positive. So by these of the few measures we can get the accuracy, specificity, recall and other terms while we are going to calculate the accuracy and precision for the model, while the model has predicted correct answer, correct of the result or not. So in this chapter we have gone through with the Bayes theorem. What is Bayes theorem actually? What is the conditional probability? That Bayes theorem is particularly that is based on the conditional probability. So what are the other related terms, important terminology is there, and what is the different classifiers are there, that is based on the Bayes theorem. So basically the new Bayes classifier that was based on the Bayes theorem, and that we are using in the classification model. So that was all about the today's class. We'll meet in the next class. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.